Okay, hi friends. Today we will discuss about the Sumpner test on single phase transformers. So the aim of this experiment is to determine the efficiency. And here the two transformers are connected back to back. And we can also find out the maximum efficiency of the transformer. And here the rating of the transformer, which we have assumed here, is 2 kVA. The primary voltage is 40 volts, and the secondary side this is 230 volts. We'll see the connection diagram for conducting the test. This is a connection diagram. Here we have to ensure that this is a transformer 1 and this is a transformer 2. So we need two identical transformers. So the rating of this transformers are 2 kVA, 40 by 230 volts. And we have to ensure that the two secondaries of these transformers must be connected in subtractive polarity. We'll see that how to find out this. Now first of all, you make the connections as per this circuit. So here this is the input to the variac. So variac, and the input supply is taken here. Now from the output, the voltmeter is directly connected across this. So here this is a voltmeter directly connected across the output of a phase and neutral. From the phase terminal, it is connected to the ammeter terminal, common terminal of the ammeter, and another terminal of 5 amps is directly connected to the main terminal of the wattmeter, and the M and C are directly short circuited here. Now from the L terminal, this is connected to 0. So this is a primary winding of a transformer 1, and this is a primary winding of a transformer 2. This is a secondary winding of transformer 1, and this is secondary terminals of transformer 2. Now here this is directly short at 0 and 0, 40 and 40. And from that L, we are directly connecting to the 0 terminal here. Now from the 40 terminal, this is bring back to the neutral terminal of the output phase. Now from the voltage terminal, again this is connected to the neutral terminal. So this completes the connection diagram for the primary side. Okay, so here up to this primary side we are finishing this. Now for the secondary side, we need to join 0 and 0 here. So 0 0 directly shorted here. So this connection 0 and 0 directly connected here. And from the outer terminals 230 and 230 or 240 240, we have to connect this circuit to the SPST switch. So this is a SPST switch, single pole single through switch, and from this we are connecting this to a voltmeter, and another terminal is directly connected to the wattmeter L terminal, here, and from the M terminal this is connected to the ammeter ammeter connection of 10 amps. Next, from the other common point, it is connected to the phase of the variac, and from the neutral terminal, these 3 terminals which are connected to the voltage terminal of the wattmeter, and next one terminal is directly connected to the 240, and next another terminal is connected to the voltmeter. This is a voltmeter. So this completes the connection diagram for the secondary side. Start the experiment. DPSC switch is closed. Now vary the voltage. So for the primary side, we have to apply the rated voltage. So the rated voltage of the transformer is 40 volts. So the variac is gradually varied to read the voltage reading of 40 volts. So the voltmeter is reading of 40 volts. Now take the readings of ammeter. The ammeter is reading around 2.5 amps, and here this is connected to a scale of 5. So this scale is 5 and it is also connected to 5. So this is a direct reading. Now the wattmeter reading is 55 watts, and here this current coil is connected in a parallel format. Now it is connected to a voltage of 75. So this is the multiplying factor of 5. So current coil is connected with a 5 and voltage of 75. So the multiplying factor is 1. So direct value we have to take here. This is a 55. Now we need to ensure that the secondary voltage must be 0. So that means the two secondaries are connected in these two secondary windings are connected in subtractive polarity. If this voltmeter reads sum of these two voltages 230 plus 230, then it indicates that these two windings of the secondaries are connected in positive polarity, additive polarity. So in our Sumpner's test we need to take that the voltage must be 0, so it indicates it is a subtractive polarity. Then after reading this it is a 0, so we come to know that these two windings are in subtractive polarity. Then close the SPST switch. Now close the SPST switch. Now after closing this, next we need to take up from the secondary side. So here I am closing the secondary side DPST switch, and next vary the variac to read the ammeter of rated current. So the rated current of this variac is 8.5, because the kVA rating of transformer is 2. So 2000 divided by 230, it will give you 8.5 amperes of current. So now the variac is varied till the voltmeter reads the ammeter reads 8.5 amps. Now this is 8.5. Now note down the readings of the wattmeter. So this wattmeter is showing a reading of 50. Then disconnected for the 600. So the 10, 600. So the multiplication factor is 8 here. Then you take the readings of a voltmeter. So this voltmeter is reading a voltage of 30, around 30 here, 30, and it should be multiplied with 2, because it is connected to 600. So this meter is connected to 600, so this voltmeter must be multiplied with 2. So after taking the readings, now bring back the variac to the initial position. Now open the switch. Next the TPST switch is opened. Now again the another variac is bring back to 0 position. So this completes the experiment. Okay, so now these are the sample readings of taken from the Sumpner's test. So here this is the 40 input voltage we are applied, then the current, no load current, and this is a wattmeter reading. And next, under short circuit condition from the secondary side, we are applying the 8.5 amps, 8.6, then wattmeter reading and voltmeter readings. The calculations. So your voltmeter reading, ammeter reading and wattmeter reading for the primary side, and these are the voltmeter, ammeter and wattmeter readings for the secondary side. Now here we are taking the two identical transformers. So the copper loss of each transformer can be taken by half of the value. So W1 gives the iron loss component or copper loss. So this is 17 by 2. So 8.5 is the iron losses or core losses of the transformer, individual transformer, and then copper losses of each transformer is W2 by 2, which is a 15 to 80 by 2. So this is 200 watts. Now the efficiency of a transformer can be taken as output by output plus losses, or it is a kVA full load into power factor divided by kVA full load plus iron loss plus copper losses. So the kVA rating of the transformer is 2000, and we are assuming that power factor of 0.8. So it is output power. This is divided by output power 2000 into 0.8 plus iron losses, which is 8.5, plus 200 is the copper losses of each transformer. So this will give you the efficiency of 88.47% for individual transformers. So this is a way of calculating to find the efficiency of a single phase transformers by using a Sumpner's or back-to-back test. Thank you.